As its campfires glow against the dark, every culture tells stories to itself about how the gods lit up the morning sky and set the wheel of being into motion. The great scientific culture of the West, our culture, is no exception. The calculus is the story this world first told itself as it became the modern world. The sense of intellectual discomfort by which the calculus was provoked into consciousness in the 17th century lies deep within memory. It arises from an unsettling contrast, a division of experience. Words and numbers are, like the human beings that employ them, isolated and discrete. But the slow and measured movement of the stars across the night sky, the rising and the setting of the sun, the great ball bursting and then unaccountably subsiding, the thoughts and emotions that arise at the far end of consciousness, linger for moments or for months, and then, like barges moving on some sullen river, silently disappear. These are, all of them, continuous and smoothly flowing processes. Their parts are inseparable. How can language account for what is not discrete, and numbers for what is not divisible? Space and time are the great imponderables of human experience, the continuum within which every life is lived and every river flows. In its largest, its most architectural aspect, the calculus is a great, even spectacular theory of space and time, a demonstration that in the real numbers there is an instrument adequate to their representation. If science begins in awe as the eye extends itself throughout the cold of space, past the girdle of Orion and past the galaxies pinwheeling on their axes, then in the calculus, mankind has created an instrument commensurate with its capacity to wonder. It is sometimes said, and said sometimes by mathematicians, that the usefulness of the calculus resides in its applications. This is an incoherent, if innocent, view of things. However much the mathematician may figure in myth, absently applying stray symbols to an alien physical world, mathematical theories apply only to mathematical facts. And mathematics can no more be applied to facts that are not mathematical than shapes may be applied to liquids. If the calculus comes to vibrant life in celestial mechanics, as it surely does, then this is evidence that the stars and the sheltering sky have a secret mathematical identity, an aspect of themselves that, like some tremulous night flower, they reveal only when the mathematician whispers. It is in the world of things and places, times and troubles and dense, turbid processes that mathematics is not so much applied as illustrated. Whatever physicists may say, both space and time, it would seem, go on and on. The imaginary eye, pushing to the very edge of space and time, finds nothing to stop it from pushing further. Every conceivable limit a seductive invitation to examine the backside of the beyond. We are finite creatures, bound to this place and this time, and helpless before an endless expanse. It is within the calculus that, for the first time, the infinite is charmed into compliance, its luxuriance subordinated to the harsh concept of a limit. The here and now of ordinary life, these are coordinated by means of a mathematical function, one of the noble but inscrutable creations of the imagination, the silken thread that binds together the vagrant world's far-flung concepts.